Hi folks, Mr. Long here. We're going to do a screencast today on the calculus portion of determining the absolute max and min on an interval for composite functions slash radical functions. So what we're doing here is we're trying to figure out, if we remember our graphs, right? So these graphs now, we know that we can have graphs that look like, that's not writing. So graphs that can look like that, right? And that's features of graphs, right? And then that would be when f prime does not exist, right? Or we can still, of course, have maxes or mins, or we can have a one-sided cusp, like a square root graph, right? And so what we want to do here is figure out what these x values are, where these things occur. And then when we're done that, then we go back to the same old strategy that we've had for absolute max and min on an interval, find out the critical values. This is a critical value where f prime does not exist. These are critical values where f prime equals 0. And over here, again, a critical value where f prime does not exist. So hopefully you have some rough sketches. And that's fairly important for you to look at those sketches so you can kind of understand what's happening. So what we do is we take our function here and we just set the derivative equal to 0, right? That's the goal here. Set that derivative equal to 0. So we have to get the derivative. So the derivative of 2x is 2. Then we do the derivative of this. Okay, so the 2/3 comes to the front, 2/3 there. And then I have to reduce that exponent by 1. So notice I do, this is 2/3, so I subtract off 3/3. So whatever the denominator is here, that's what I use right here for this, to make a whole, make 1. So that becomes negative 1/3. So what we do then is we then go down to our next thing and we recognize that negative 1/3 means that that is a that is division because it's a negative exponent, so it's 4 divided by x to the 1/3. Now, what I see right away here is I'm dividing by x. So what would happen if x was 0 here? I would have 4 divided by 0, and my derivative, my tangent slope function, wouldn't be it would be undefined, right? So anytime this bottom is 0 in the derivative, as long as that x value is defined in the original function, that is a point, is also a critical value, and f prime doesn't exist there. So that's when you get one of these features like this, or one of the cube root graphs, which look like that, right? Something like that. Okay, so, and then we solve this equation. Now there's a variety of ways to solve this equation. You could put 2 on one side and 4 over x to the 1/3 on the other side and just cube both sides to get rid of x to the 1/3. What I did is I got a common denominator here, right? So the lowest common denominator is x to the 1/3, so I have to multiply the 2 by x to the 1/3 over x to the 1/3, which is the same as multiplying by 1, and then subtract that. And on the next page, as we go through this, you'll see what we did. So got a common denominator, right? And then this is my numerator right here. Okay, and then, so we have, oh, well, I thought for a second I was going to lose everything there. Okay, I'm glad we didn't. So I'll get the, there we go. So again, I've got this common denominator now, and what we're going to do is solve this equation, right? So if I want a fraction to be worth 0, the top part of the fraction must be worth 0, right? So that's why I set this thing here equal to 0, and I solve that equation. So add 4 to both sides to get rid of that negative 4 there, or subtract 4. Then divide both sides by 2, right? And then I have x to the 1/3, which is another way of saying cube root. How do I make that exponent worth 1? 1/3 times 3 is 1. But if I cube the left side, I have to cube the right side. And then x to the 1 equals 8. That's a critical value. It's a stationary point because that's what makes the slope 0. So it looks like this or this at x equals 8. And then when I go to do my table when I substitute in my left boundary, my right boundary, or the endpoints of the interval, that's one of the x values I substitute into the table. And then also x equals 0, as we mentioned before, and I can see it here too. If x equals 0, this whole thing becomes undefined, right? It's a huge, huge number. So that's also a critical value where f prime does not exist. And that's where we get these types of features, a two-sided cusp or a one-sided cusp. All right, let's move on. So this question here is like number 6 or number 7. It is number 8 actually. So it's like 6 or 7. And so the questions that you should be doing, once you watch this video, you should be able to do 6 or 7, right, and finish it out. So so what we're going to do here is we look at this and we notice that there's a function, x squared minus 2x, inside a function. So that means we need to use the chain rule. So I always call my inside function u. X squared minus 2x is u. I do du by dx, 2x minus 2. Then I have my outside function is 3 multiplied by the inside function to the 2/3. So then I do that derivative. And again, 2/3 comes to the front. Ooh, Mr. Long. I forgot my 3 right here. So that should, ooh, that's a bit of a problem. I'm just going to do some quick corrections here, folks. I'll be right back. You know, that's a really lucky mistake to make because it didn't change any of my answers. So again, so what I forgot to do with that 3 there, I did not put it in front of the u, which I should have left it there, right? It's a coefficient, it stays. So anyway, I went through that and I made sure there was no effect on at all on the solution. So that 3 is not there though, right? So because 3 divided by 3 is 1. Okay, so there's our dy by du is 2 over 3u to the 1/3. So I come over to here and then I write out the chain rule in full. So remember that I multiply du by dx by dy by du, right? I multiply those two together for the chain rule. So it's going to be 2 multiplied by 2x minus 2, and that becomes my numerator. Then the bottom is u to the 1/3. Well, what's u worth? It's worth x squared minus 2x to the 1/3. Now, when there's no product rule in the question, I always move my anything that's a negative exponent, I move it to the bottom and make the exponent positive. Okay, I'll repeat that. If there is no product rule in the question, then I would always leave this as a positive exponent when I do the chain rule. Okay, so how do I solve this? So if f prime equals 0, where I have a min or a max, I would set the top equal to 0, right? And so that works out to x equals 1. So that's what's called a stationary point. It's a critical value, but it's also a stationary point. Then I need to look at when does f prime not exist? Well, anytime I divide by 0. So I've got to let the bottom be 0. So x squared minus 2x equals 0, common factor out the x, and then I get x bracket x minus 2. So that means at 0 and 2, I've got features like this, okay, in my graph. But again, we would have saw that in our original rough sketch anyway, right? In our original rough sketch anyway. So, and that's the thing that I want you to think about. So you do your rough sketch first. Really, your calculus is just going to verify your observations from that rough sketch. So once you've gone through this example, you could tackle 6 and 7. And so previously, once you did this question, which is number 5, you'd be able to do 1, 2, 3, and 4. Okay, so let's go on now. So now we're going to do some product rule questions, and I think what I'll do is I'll end this video here and then I'll work through the product rule questions because they are a little bit different. Okay, that'll be part 2 of this set of videos.